Here we go.
Moving on. My last story, Tom.
What do we got here?
This is a NASA story because
huh?
you know me, I'm always a big space fan. Yeah, exactly. So NASA on Twitter.
Fortnite and Tide Pods. Be careful out there, guys. Get your good sleep.
NASA on Twitter says the top of Jupiter's atmosphere is dominated by different colored bands blowing in different directions. How deep do they penetrate?
Oh.
And what drives them? New science from our NASA Juno spacecraft indicates some are about 1,900 miles deep. Discover more. So there's going to be a little video that is part of their tweet that hopefully we'll have kind of playing in the background now. But I wanted to not so much focus on this video. I thought it was cool. NASA Juno spacecraft is fascinating, right?
Yeah.
I mean, this
we got
unbelievable
pictures and amazing stuff.
Unbelievable cameras looking at Jupiter and kind of below the surface of Jupiter to really get an understanding of the mechanisms of what we see on the surface is just mind-blowing. So I'll let you guys take a look at that. There's some cool stuff about how the bands are kind of blowing in different directions, and what causes that must be very deep underlying in the surface because there's mass moving in one direction, and then right below it there's mass moving in the other direction.
Which is weird.
Yeah, this is weird.
Because, as you would think, Jupiter is a big planet and rotates very quickly. So you could see how the gases could all be rotating in the same direction. That would make sense.
Correct.
But when you see them moving in different directions, that's some funky stuff.
Right. Yeah. And then below all of that, they think that there's a solid, rigid body. Right. What that's made up of is anybody's guess. I've heard things about solid hydrogen, which is like a material we don't even know about. Beyond all that, Tom, I wanted to bring up some images from NASA's Juno GIRAM camera. Ooh. Right?
Okay.
GIRAM stands for Jovian Infrared Auroral Mapper. Auroral. Yeah, you can tell I've had a couple of these.
I'm just joking.
And these pictures were really making their rounds on social media, on Twitter. So I'm going to have Kyle bring up some of these photos for us because they're quite beautiful.
Cool.
And we were talking about tattoos in the last story that I brought up.
You want to get a juke tattoo?
These would be fucking awesome tattoos.
Very cool.
You get the North Pole cyclones on the dome, right on the forehead.
That'd be good.
And then maybe the South Pole right on the right butt cheek.
Okay.
Yeah, you know what I'm saying. All right, so
real quick before you get into that, someone in the chat said the octagonal storm at the poles. I think they're talking about the hexagonal storm on Saturn.
Could be, but
Jupiter has one of those?
Here we go.
Okay. Here we go. Okay.
From the NASA press release, they say, quote, "A truly striking result released in the Nature papers is the beautiful new imagery of Jupiter's poles captured by Juno's Jovian Infrared Auroral Mapper, or GIRAM, instrument. Imaging in the infrared part of the spectrum, GIRAM captures images of light emerging from deep inside Jupiter equally well, night or day. GIRAM probes the weather layer down to 30 to 45 miles below Jupiter's cloud tops." Now, goes on to say, its north pole is dominated by a central cyclone surrounded by 8 circumpolar cyclones with diameters ranging from 2,500 to 2,900 miles across.
So they're basically giant hurricanes.
Huge hurricanes.
Massive hurricanes.
Massive. Exactly. Jupiter's south pole also contains a central cyclone, but it is surrounded by 5 cyclones with diameters ranging from 3,500 to 4,300 miles in diameter.
That's huge.
Huge. Almost all the polar cyclones at both poles are so densely packed that their spiral arms come in contact with adjacent cyclones, so they're all kind of touching one another. However, as tightly spaced as the cyclones are, they have remained distinct, with individual morphologies over the 7 months of observations detailed in the paper.
Yeah, they're not going anywhere.
Right.
Yeah.
They're persistent. They just exist as the way that they are. The question is, quote, "Why do they not merge?" Says Adriana, one of the study kind of co-authors here.
Because they're gases, they're fluids, right?
Exactly. We know with Cassini data that Saturn has a single cyclonic vortex at each pole. We are beginning to realize that not all gas giants are created equal. So Kyle's throwing up some of these images here of these storms that are kind of in sequence with one another, surrounding one giant storm, and somehow they don't mix and form one more energy efficient storm.
Or at least change more over time. Even if it's chaotic.
Right.
They don't even really change.
Right.
Yeah.
And that is somewhat in line with Jupiter's Great Red Spot,
That
right?
has
Which
always
we
been
know
there, yeah.
has been there for hundreds of years.
Because people have written about that since they started observing Jupiter.
Right.
Yeah.
Why are these storms the way that they are, Tom? This is very,
Yeah.
very intriguing, very fascinating to me. I can't really think about it in terms of physics because it's breaking physical laws in my mind.
In terms of what we know.
Right.
Yeah. So Jupiter, it's huge.
Big mystery.
Yeah, it's really big, and I guess we just don't know enough about the atmosphere, the gases, the pressures, the rotational speeds. It's just, it's a little bit beyond our understanding right now.
Yeah.
And hopefully, we'll get there.
Yeah. So
And as we understand our own planet more, we'll probably understand Jupiter more. And as we understand Jupiter more, we'll probably understand our own planet more.
that's
So
what's
why
awesome about
we
it.
gotta
Yeah.
study it.
Yep.
Yeah.
Yep.
So maybe once we unlock the mysteries of Jupiter, we'll understand why we had Harvey and things like that.
Exactly.
You know?
Yeah.
That's the goal of NASA.
That's the dream.
The dream. Yeah.
Exactly. Cool.